So what is matter? Matter is anything that has mass and occupies space. And what is mass, this thing? Mass is the amount of matter that something is made of. And space in this context is the amount of space taken up or occupied by an object. Let me show you um, let me show you this intuitively. Let's say we have this water and someone did the calculation and came up with 1,000 grams. 1,000 grams. Let's say next to it we have this bucket, could hold 2 liters of anything, and I'm measuring it, 2 liter up top, 1 liter here. So let's say we take this water and dump it into this bucket. What happens? So this water settles to the bottom of this bucket and takes up 1 liter of this bucket. So in this context, we can see that this water is our matter. And we said that matter is anything that has mass and occupies space. Here's its mass, and it's occupying 1 liter of space in this bucket. Here's the space. So mass and space. So anything in this world that we can touch and see is made up of water. Matter. Your computer, your laptop, your clothes, everything is made up of matter. So the next question is, what is matter made up of? So matter is made up of mostly in our universe and in universe in general, um, of about 118 elements. Let me show you these 118 elements. Here's number one, and here's a 118th element. We are familiar with some of these, I think, like hydrogen, carbon, nitrogen, oxygen, but not with most of them. Um, I said that 118 elements make up what is in our universe. It's not really true. Um, Only about 100 of those elements actually make up what's in our world. And more interesting, biological things like us um, are only made up of elements, substances like carbon, hydrogen, and oxygen, and few other things like these metals, like calcium, for example. So, um, elements are substances that cannot be decomposed into simpler substances, and can exist as either atoms or molecules. So these elements can either exist as atoms or molecules. So what do I mean by that? So what is a atom? Atoms are almost infinitesimally small building blocks of matter. So these things are each individual of these things are atoms. And molecules are two or more atoms joined together in a specific shape. Like for example, I'll show you an example. Let's take let's take this hydrogen as an example, and I'm going to draw it as a circle. So if I put these two hydrogens, join them together, I have a molecule of hydrogen. So two hydrogens connected, joined together. Here we have a molecule of a hydrogen, but alone we call this either element or an atom. So what do we call something that's made up of more than two uh, different atoms? We call that a compound. Compounds are made up of two or more different types of elements. In other words, two or more kinds of atoms. Like in this box here. Here, let's say we have a carbon, joined with hydrogen, 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 4 hydrogens. In this case, we have two different atoms making up this molecule. So uh, we don't call this a element or an atom because two or more atoms make up this bigger thing that we call a compound. So we call this a molecule of a compound. But if you have, like, for example, I said two hydrogens, two of the same atoms making up something, we call that molecule of an element. And this right here, one hydrogen by itself, we call that just an atom. And then we have mixtures. So this together with this and this, we call that mixture of compounds and elements. So let's move on. Classification of matter. So there's three states a matter can exist in. We have gas, liquid, and solid. We'll start with gases. So a gas has no fixed volume or shape. It uniformly fills its container. What do I mean by that? Let me show you an example. So let's say I have this container, and let's say I have a piston on top of this container, a piston that I can move up and down, and nothing can escape from this piston. And I'm gonna show these gases as these little dots. So you can see that when we put gases in a container that is sealed top, we'll see that the gases just spread all over this container. They don't all go in one place. For example, this corner or this corner, or right or in the left corner, bottom corner, or in the middle. They're uniformly fill the container. And one interesting thing about gases is that if I put pressure on the piston, and for example, let me show you. So I put some pressure in this piston and I lower it up to this position. Let's say this is my original piston and I've lowered it. What happens, these gases all of a sudden move, and now they're a little tightly more together. But this is what is cool thing about gases, that you can compress them. And then as soon as I let go of this piston or I move the piston up, they go back to, it goes back to its, it goes back to this position where they again fill the container uniformly. Um, let's talk about liquids. So liquid has distinct volume independent of its container. Assume shape of the portion of the container it occupies and is not compressible to any appreciable extent. So what do I mean by that? Let me draw that. Let me draw another container with a piston. So let's say on top of this we have a piston that nothing can escape from, and on the bottom of it we have liquid. And you can see that the liquid is not uniformly filling this container. When I add this amount of liquid, it resides all the way to the bottom. It takes the shape of the bottom of this container. So it says that this right here assumes shape of the portion of the container it occupies. So this portion only is not uniformly um, covering the whole container and is not compressible to any appreciable extent. So when I bring the piston, so if I push the piston all the way here, and then I try to go further down, so if I try to push the piston further down, I cannot because water is not compressible. So just remember that. Liquids are not compressible, in other words. All right, let's go on to solids. Solid has no definite shape, a definite volume, and is not compressible to any appreciable extent. So what do I mean by that? Again, let's say I have a piston. I mean a container with a piston on top. Draw that a little better. And then I have this piston on top that nothing can escape from. And let's say I add some solids. let me just draw these solids, make them look like they're solid. As you can see, when I add these solids, also they don't, like liquids, they don't uniformly fill the whole container. But one interesting thing from if you compare liquid to solid is that you can see these little spaces in between these solids that are not covered compared to a liquid that fills the whole, all of the space, everything. There's no space in between um, liquids compared to solids, so many spaces between these solids. And if I try to lower this piston, so if I bring the piston down up to here and I try to lower it even further, I cannot because solids again are not compressible. I mean, you could put a lot of pressure and break these solids, and still you'll have these little spaces in between them, those solids. Yeah. Let's move on to mixtures. So substances that make up mixtures are components. What do I mean by that? So if I have like this, so what is components? So if I have some some beaker with some water in it, and inside this water there's mixed salt. The two components that make up this mixture is water and salt. So whoops, water plus salt, which are the components, that make up this mixture. So two types of mixtures. We have heterogeneous mixtures and we have homogeneous mixtures. Heterogeneous mixtures, mixtures that do not have the same composition, properties, and appearance throughout. You see this everywhere in your life, like rocks are heterogeneous mixtures, because if you look at a rock, many type of minerals make up a rock, and you can see there's like one part of a rock is a little darker than the other. It's not uniform. And if you look at like a wood, for example, you see these little dark spots in the wood. It's still not uniform. A wood is also a heterogeneous mixture. On the other hand, homogeneous mixtures, they're mixtures that are uniform throughout. For example, air is uniform. If you look at air right now, you don't see any patches or anything but a clear air. Also, and like we showed this example, salt and water inside a beaker, and if you mix the salt, which blends in with water, mixes with water, that's a homogeneous mixture. It's uniform throughout. And another example would be sugar and water. In chemistry, homogeneous mixtures are usually called solutions. Solutions. And in chemistry, you're going to deal with a lot of liquids, but just remember that solutions are also uh, can be solid and gases. So one way to figure out if you have a heterogeneous mixture, homogeneous mixture, or if you have like a pure substance, for example, element or compound, is to take it through this diagram. So if I give you pure water, like distilled water, and you go through this process, the first thing you want to ask yourself is this is this water uniform? Uh, yes, I would say water is uniform, so you would say yes here, and then it would make it a homogeneous mixture. And then the next question you ask yourself is, does it have variable compositions? So like a distilled water doesn't have distilled compositions. It's usually